For the class of integrals of the form, the integral from 1 to infinity of 1 over x to the p dx, we have something called the p-test that allows us to use the value of p to determine whether or not the integral is going to converge or diverge. We'll take a look at that test now. We're going to look at the integral from 1 to infinity of 1 over x to the p dx, and we're going to see that for different values of p, we're going to get slightly different behavior. So we're going to have to consider a couple of cases. The first case we'll consider is when p is not equal to 1. We're also going to assume that p is not 0 for all of these cases, because that's an uninteresting case of the function. So when p is not equal to 1, then we know again that this integral is going to be the limit as b approaches infinity of the integral from 1 to b of 1 over x to the p dx. And since p is not 1, this becomes the same thing as the limit as b approaches infinity of the integral from 1 to b of x to the negative p dx, which is the limit as b goes to infinity of x to the negative p plus 1 all over negative p plus 1 evaluated from 1 to b. When we plug those limits of integration in, we get the limit as b goes to infinity of b to the, I'm going to rewrite that as 1 minus p over 1 minus p minus 1 to the 1 minus p over 1 minus p. We still haven't taken our limit. I'm going to tidy this up a little bit algebraically by factoring out a 1 over 1 minus p, and that's going to leave me with b to the 1 minus p minus 1. Okay, now we're going to notice a couple of things. We're going to again look at two different cases. So our first case is going to be that p is less than 1. If p is less than 1, then we know that 1 minus p, so 1 minus a number smaller than 1, that is going to be positive. That is going to be a positive number because we're subtracting something smaller than 1 from it. That includes the negative case. If we do 1 minus something like negative 2, we get a positive number. In that case, b to the 1 minus p, as b goes to infinity, we have a positive number raised to a positive exponent going to infinity. That is also going to go to infinity. So that means that this limit is going to be infinite in the case where p is less than 1. And so that tells us that the integral from 1 to infinity of 1 over x to the p dx diverges in the case where our p value is smaller than 1. We're still in the case where p is not equal to 1, but we have a second case we could consider, case 2, where p is bigger than 1. In that case, 1 minus p is a negative number. And when that happens, b raised to a negative power, as b gets larger, is going to get smaller and smaller and smaller and is going to go to 0. So we're going to see here that then we have the limit as b goes to infinity of 1 over 1 minus p times b to the 1 minus p minus 1 is going to equal negative 1 over 1 minus p, which we can rewrite as 1 over p minus 1, which will be a positive number. It's an area, so it better be a positive number. It's an area of a function sitting entirely above the x-axis, so it better be a positive number. We get 1 over p minus 1, and that converges. Now, if we go back to our original question, we want to now look at the limit as b goes to infinity of the integral from 0 to b, from 1 to b, of 1 over x to the p, where p equals 1. So that is the limit as b goes to infinity of the integral from 1 to b of dx over x, which we know is the antiderivative of that is the natural log of the absolute value of x evaluated from 1 to b. So here we're going to get the limit as b goes to infinity of the natural log of b. B is positive because we're to the right of 1 here, minus the natural log of 1, which is of course 0. So we see that this is the limit as b goes to infinity of the natural log of b. But if b is getting larger, its natural log is as well. So this is also unbounded, infinite. So we see also that this integral diverges. So we have 3 cases. We'll wrap them up all here. So we have the case where p is less than 1. When p is less than 1, then we see that the integral from 1 to infinity of 1 over x to the p dx diverges. When p is equal to 1, because this becomes a natural log, this also diverges. But if p is bigger than 1, then the integral from 1 to infinity of 1 over x to the p dx converges, and in fact is exactly equal to 1 over p minus 1.